what is happening to Iceland, or we should say in Iceland also. It was in the late winter 2021 that we noticed that there is a lot of seismic activity near the capital of Iceland, Reykjavik. The center of this activity was in an area that is shown on this map, as you can see. This is not very unusual, but we are observing that area for a long time. We noticed seismic activity, we noticed a slight rise in the ground also. And our gravimeters, the devices that measure the gravity, noticed that there is a slight increase also, about a slight increase in the amount of the Earth gravity in that direction of this center that you see here. As if something is under there, bulging up gradually, building itself up, gathering material. Is that unusual in that region to have seismic activity? As you can see in this global map, this is a global issue. We have what is called mid-Atlantic ridge in the Atlantic Ocean. We have the same ridges under the sea, on the seafloor, in places like Pacific Ocean, Indian Ocean. These are the places that we have discovered in 1950s and 60s, that the Earth is actually expanding from that region. Earth is made of several plates, as we call it. They are the slabs of the earth ground, that earth material, crust material, that are floating on a mantle of the earth. And now we know that this, there is a convection cell where these cells create a motion in the these tectonic plates, as we call them, dragging them into a trench, and then they sink by their own weight into the mantle of the earth. They may come up later at some other point due to the, being heated up and so, at a place that we call ridge. This ridge forms because the weight of the slabs is actually pulling apart that center. And the pulling apart of those parts create what we call as the mid-Atlantic ridge. So these plates are being pulled down, they sink into the ground, to the mantle, then they come up at another point where this uplifting of material is happening. They almost touch the core of the earth, these slabs, when they reach the deeper mantle. And when they rise up, because they have lots of water, remember, they have been in the water, they have been at the depth of the water in the ocean, they are moist. And the moisture actually creates this kind of, uplift of the material. They became able to boil or get heated up at a lower temperature. They're rising anyway. As we see, there is a hotter spots on the, maybe even deeper core has these hotter spots. We call them plume. And these plumes are actually, one of them is what is on the Iceland, as you can see here. The slab has sunk, and another point, plume is rising from the mantle of the earth at the core and mantle boundary. These convection cells, as you can see in this image, are something real. We can actually map them. This is done by seismographs, global seismographs. You can see the pattern of this. Some of them are in the Indian Ocean, some of them are in the Pacific Ocean, some of them are actually under the continents. In the Africa especially is the biggest one of them. Africa probably is the most important tectonic plate, and more stable, and most stable than many of them, or other ones. In this other map you can see the same. These are created by measuring the speed of the travel of earthquakes inside the earth. Our seismographs are picking up these signals, and we can actually map them like that. So at the Pacific Ocean we have this phenomenon of opening of the ridge, opening of the ocean in the middle of the ocean. We are lucky in Iceland that is happening on land practically because of this mantle plume rising there. We can actually see this. It has created mass of land. This mass of land is gradually expanding. In the next, in here now you can see that the edge of this ridge is actually being recreated all the time, reborn. New edge is created. That is exactly what's happening in Iceland. And it's usually at 5 kilometers down in the ocean depth at the oceanic crust. But in Iceland we can see it at the surface. And this mantle plumes rising there, they're very hot, but they're not boiling. When they reach the area here, you can see, because the pressure is removed from them, is a slightly less pressure, they start to boil. And that boiling creates a magma chamber. Magma chamber also, if it finds a way to the earth, which is in this case in the above the crust, you will see it as a kind of volcano. This volcanic activity happens all the time on the ocean bed, in the ridges, what we call expansion ridges, extended ridges. But in Iceland, this happens on land, and there are evidence that in Iceland we can actually go and see these things, the expansion ridges. We can date these ones. Every one of them has a different magnetic signature, north and south at the time of the this magmatic and lava eruption is frozen inside these rocks. When they're molten, they align themselves to the magnetic field of the earth. When they freeze, the magnetic field of that moment is preserved. In Iceland, we have this at the surface of the earth. You can see that they're expanding. On the right side, you see the Eurasian plate, which is the biggest, one of the biggest tectonic plates. In the left, you can see the North American plate, and Iceland is at the boundary of this. Is the ridge there. Iceland is a place that actually the land is being created. We can say it's the core of a new continent, practically, we are seeing. Iceland will become bigger. No matter what happens in the rest of the Atlantic, Iceland is going to be bigger. The land building is happening in front of our eyes in the form of this volcanic activity, recent volcanic activity. You see how it expands, covers newer areas, adding to the land mass. And if it reach the sea, you will see that Iceland will become a little bit bigger even. And as the Rift Valley, this is what we call Rift Valley, from the valley you see in the diagonally, from the bottom right to the top left is a Rift Valley, similar to what we have in the Rift Valleys of Africa, or Rift Valleys in the Red Sea, in Palestine, in the Jordan, up to Lebanon and Syria. You can see them also in Ethiopia, down in the Afar Triangle, Eritrea and Djibouti. Also we have in Europe, in Rhine Valley we have that. It's from Switzerland. Can you believe it? From Switzerland to France, Germany and Netherlands and the North Sea, we have actually a Rift Valley. It's not active anymore, but it exists there. Similar to that, we have it in Iceland. Land masses are being created, as we see in this volcanic eruption, as we see the development of the lava flow going down, covering new land. If it reaches the road, it will cover the road. Internet cable is already covered, part of it. And if it reaches the sea, you will see a expansion, creation of land for Iceland. In this satellite image, you see that when it reaches the sea, that rift, that diagonal valley, is a continuation of the mid-Atlantic ridge. This volcano happened like that, added a lot of lava. It seems it's not going to stop. This kind of volcanic activity, because the source of them is deep in the mantle, they will continue for a long time. They will not stop soon. It's not like a Stromboli or Etna or Mount St. Helens that have a little bit activity, then several weeks or months or years will not be active. These are going on for a long time. The source is very deep, is almost endless. The earth mantle is there to supply it with the new magma. So this flood of the lava will continue and will eventually reach the sea, reach the ocean. The flow of lava will cover a vast area. That valley will be covered, and it may even, this fissure, this opening crater be closed. It may start from another point. And eventually it will reach the sea, add to the mass of the Iceland, in a way. This is good because we can actually go and see it. Of course, the land mass being created, but at the same time, the access roads are beginning to become limited. As you can see, the cameras here that we have in Iceland are now surrounded by lava. The maintenance of them is only done by